Hello, IBSL2. Tonight's topic is our beginning of our statistics and probability unit, and we're going to start off with statistics, and it's 8.1, and we're going to be talking about continuous numerical data. We have some definitions in the beginning here. The first is to understand the difference between continuous numerical data and discrete data. And continuous numerical data is data that is measured, and discrete would be distinct data. So if you think about students in a classroom, if you were counting those students in the classroom, then that would be a discrete data, because you can't have half of a student, so you would be counting and you would get a total number or countable data. Now for continuous, we're talking about measurable data. So if we were measuring the student's height, or they're measuring their shoe size or other items that are measurable data, then that is continuous data. And tonight we're going to be talking about continuous. And we'll be learning about how to use a histogram, where we're going to be displaying continuous numerical data, and the vertical axis is going to be the frequency, and the horizontal axis is going to be the range of the values. All of our column widths will be equal with our histogram, and our height is going to vary according to the frequency. Groups into class intervals, and there'll be no gaps between the columns. And there's two types of histograms. We can just have a frequency histogram, or the frequency histogram can be put in percentages, and that would then be called a relative histogram. So that's just the definition. We're going to be practicing more and explaining that further. Just make sure you have the definition down. The column graph is what you're used to seeing, and seeing a lot of data in column graphs, and that's for discrete data. You can have gaps between columns, and the data is usually countable data, discrete. The modal class is the class of values that appears most often when you're looking at your histogram. And then we can have two different kinds of data. Positively skewed data, and that would have the median is before the mean. So the mean is then being skewed in the positive direction by the outliers. Or we could have negatively skewed data. And in that case, our mean is before the median. So our mean is skewed in the negative direction by outliers. Again, we'll be talking more about these definitions as we go in our video tonight. First, let's get a handle on what a frequency histogram looks like. And we're going to start by constructing a frequency histogram, and then we'll talk about the relative frequency histogram. The data we have has heights of a basketball squad in centimeters. So I know it's March Madness right now, so I thought this was an appropriate data to be talking about. So this basketball squad is obviously not in the United States. Their height is in centimeters. And we're going to be constructing a frequency histogram using these heights, and the data is our frequency. That's our numbers. So our x-axis is going to be our height, our range of values, and then our y is going to be our frequency. So it is important to set up, make sure our column widths are equal. We must have the same column within same range in each of our columns here. And we start off by our 170 would be here, and that doesn't look so high. Let me fix that 0. And then 175 would be our next break here. So if we, on our horizontal axis here, we have 170 to 175, and then our next spot will be at 180, and then at 185, 190, 195, 200, and then at 205. Our frequency, our highest frequency is going to be 11, so we want to step up, and 12 would probably be the highest we have to go to. Okay, I'm going to bring this down a little bit. All of our data set here. And you want to just step up with ones from 0, 1, all the way to 11, or if you can go higher to 12, depending on how much space you have. And I'm going to stop at 11. That's as high as I have. And I do want to make sure my 0 is right at 0 there. So I'm going to pull these down some. Okay, now we're just going to draw a histogram, and all of our columns there'll be no gaps. Remember, that's part of the definition. So first we look at our range from 170 to 174. We have a frequency of 1. So that means there's one basketball player within that height. So we will color in to 1 there. And we can fill this in. From 175 to 179, that's a frequent height. There's 8 students, 8 basketball players in that height. So we'll go all the way up to 8 here. Okay, so I think you get the idea. Go ahead and I'm going to pause and straighten my lines out here, and go ahead and fill in the rest, so that you'll have 9 in this area, 11, 9, and then 3 and 3. So go ahead and fill in your chart and then bring it back. Okay, so your histogram should look something like mine here. And again, what we're drawing is we're telling what is the frequency in this range. So, and all of your, it's very important that they're all touching each other. There should be no gaps. Also, it's also very important to label your graph. So there should be a title, and my title for this one would be the heights of a basketball players. And then also you want to put titles in your for your horizontal and your vertical. So the appropriate one for the horizontal would be the heights in centimeters, and then for the vertical would be frequency. Okay, we have a couple questions here. What is the modal class? And remember, that's the class of values that appears most often, and that's one of the advantages of the frequency histogram. And here it's quite clear that it is from 185 to 189. The second question is asking you to describe the distribution of the data, and it appears that it's slightly positively skewed. Alright, let's review for a minute the mean, median, mode, and skewness. How is the data spread? So first, let's just remember what mean is. Remember, mean is you sum all of your data values, and you divide by the number of your data values. And also remember the different items that you see. We have the X bar when it's representing the mean of a sample, and then mu would represent the mean of a population. And remember what those words mean. My parents, they're involved with sampling a lake on the Sassafras River. They live near that river, and they take a sample of that river to test the quality of that river. So it's pretty impossible to sample the entire river. So that's what it means when you are taking a sample. You're trying to get an idea of the entire population. It'd be very difficult to get from entire population. If you can, that's what we do every 10 years with our census data, then that's when you will see the mu. So a lot of times the sample just helps us save time and represents the population. For the median, it's the middle value of your ordered data set. So you put the numbers in order and find the middle one. The mode would be the most frequently occurring data. So I want you to just try to remember how to find all these. Go ahead and find, with this example, we have a number of trucks using a road over a 13-day period, and we have 13 data sets. So go ahead and find your mean, median, and mode and bring it back. Okay, for the mean, you should have found that there was average of 5.08 trucks on the road. The median, you have to put the data in order and find the middle number. For an odd, it's number, it's pretty simple. It's the, I just count, I know there's 13, so it would have to be the 7th number in the middle there, so I can count from this side to 7, or from this side from 7. If it was an even number of data, then you would average the two middle that are in the data. Another way to do it is take your value, the number of data sets, and then plus 1 and divide by 2 to find the number in the middle. For the mode, we're just determining what is the most frequent number. So obviously from looking just at the data set in order, you can see that there the mode would be 6. Alright, so one thing I forgot to mention before I started talking about mean, median, mode was about the relative frequency histogram, and that would be when you would take your data and put it into percentage, and that's what you would chart. So it would say the frequency, the percentage of the frequency. So that's what that's the difference between the relative frequency histogram and a frequency histogram. Last topic tonight is how you find the mean when it's in group data. So here we have a frequency distribution for the rise and tides, and we have it set in a frequency. So I want you to go ahead and pause the video and write all of this information down. Okay, so anytime you're not given your exact data, you will have to be estimating our mean. So we don't know each data point, so all we know is the frequency. So what we're going to do is be taking the midpoint, the average. That's the best way to estimate the mean here. So we're going to be finding the midpoint of each of our areas here. And then we're going to be taking that midpoint and multiplying it by the frequency and putting it in this column. Because our formula is to find the mean is the sum of the product of the midpoint times the frequency divided by the frequency, the sum of the frequency. So go ahead and try that. You should have found all your midpoints and multiplied each one by the frequency. Sum that up and got 1665 and divide by 30 for 50.